to talk about streaming financial data, obviously with queues. And here's the TLDR version of this presentation. I'll go over the motivation for the project twice. That will be there will be a one-on-one introduction to finance in between, but that should allow us to go over the solution overview. And later we'll see how to build the API that gets the queues in place, but also a few cases where the API either defends from additional requests, or we're at the cost of increased implementation details. We'll have to change a few bits and pieces. And finally, because this is all about producing numbers, we'll be able to see a set of numbers telling you how fast you can create them. So let's state the obvious. What we need is to live stream forward trades for our hedgers when they engage with customers that want to hedge currency exposure. So that's crystal clear. Now if you have no idea what I've just said, that's fine. There will be a few next slides just to catch you on the topic. There is a quote from Investopedia speaking of hedging, and this is totally not Wikipedia for finance. That hedge is something you buy to reduce the risk of price movement. Now what does that even mean? Let's assume for a second that each of you own a company that produces butter and cheese. And in order to do that, you need to buy a certain amount of milk. By the way, did any of you notice that the price of butter went up during the last month? I did. Now at the beginning of the year, you know the approximate amount of milk you need to buy. What you don't know is the price. If it goes up, you will earn less money. If it goes down, it's better for you. But the point is that regardless of what you're doing with your core business, you cannot control it. Nobody can. There are companies that can give you a rough estimate, but nobody has the crystal ball telling you the exact price. So what you're looking for is something, some contract or investment that lets you set the price. And how do you usually do that? So obviously, if it has something to do with money, you go to the bank. Why banks? Because their core business is dealing with money and the risk, and that's something that you don't want to do. So if we simplify the example a bit, and just assume that at a certain date in the future, let's say 1st of November, you will have some amount of foreign currency. In this example, you're a, let's say, US-based company, and you report your earnings in US dollars. Unfortunately, or fortunately for you, you also do business in Poland. That means you will have a stream of Polish zloty as your revenue. But the truth is that your management and investors, they finally care only about the number of, or the amount of US dollars that you make. Even if you have a terrific year, if the USD PLN strike rate goes down, nobody cares what you earn. And the simplest way to go over that is to call your bank and say, hey guys, I have some amount of Polish zloty at the end of the year. I want to exchange them to US dollars. Can you give me the price? That's called FX forward. That's a just agreement to do that on the future. You fix the strike. You know the strike in advance. And that really limits your risk. Obviously, since you don't know the exact amount of money, you usually don't want to overhedge yourself, and you set the limit of money slightly below. Forwards are also particularly simple because it's easy to know where you are at the market. You just compare the rate that you have on the forward against what you currently see. Now, just to reiterate over that, there are several reasons for why you want to do it. First of all, most companies have only limited amount of money. And even if you have large cash holdings, you really don't want your earnings to fluctuate due to the reasons that are way out of your control. And the other thing is usually connected to reporting or accounting. If you're a publicly reported company, other people can buy your stock. It means you have to report your financials. And anything that is on the balance sheet, if it can change over time, that may affect your stock price, which either means that you lost money and that makes management upset, or you gained. That's a favorable case, but it may also be rare. So that's why you usually are searching for an institution that can support you, and that doesn't mean the risk goes away. It's just that you transfer it to a different counterparty. Usually it means bank, because you really want that counterparty not to default, and banks collapse rarely, unless it's 2008 again, you're dealing with Lehman Brothers, nothing bad should happen. So now let's go over what we actually need to do again. So far we know that we have a client, they will have an inflow of foreign currency, and they want to convert it to whatever currency they need. And usually the case is that they want to purchase FX forwards. So when they engage with our consultants on the phone and they agree on the economics, we need to provide a way to live stream the actual rates and all the prices and how they change over time. That just really speeds up the execution and provides better user experience. So far, we went over two types of rates. So the first one is the exchange rate. That's something what you get right now. And there are usually two properties associated with it. So this is the bid price and the ask price. They reflect whether or not you want to sell or buy. And there is usually a spread involved. That's also the explanation why you really don't want to exchange your currency on Florianska Street or any other street that is close to Market Square in Krakow. And the other type of the rate is the forward rate. That's the value of the currency you will get in a year if you engage into contract right now. That obviously changes over time. If you buy a 1 year forward in the next month, the price will obviously be different. So we can consider the type as the ID. We of course introduce something called the mid price or the fair price. That's just for easier calculation. And all the rates are valid for a certain timestamp. So how do we get them? There are providers. Their main job is to aggregate quotes from different banks and different brokers, make sure they can be trusted, they are liquid, valid, and so on. And in case of our provider, we have a pretty simple model to get them. They have an event-based API. What you want to do is to just connect to it, specify IDs, perhaps dates, and some fields that you're interested into, and they will notify you when anything changes on the market. Updates are obviously partial, just to limit the number of data sent over wire. So you have to take that into consideration as well. Now this was the initial graph that we invented, and this is the only part that we knew. So we're getting data from somewhere else, and now we have to do something. This is the business logic circle is the magical black box that will somehow push everything we need to clients. And since we want to push it, there is this idea of clients connecting initially. So, well, they have to say, hey, I want to see that rate. And the rate store is obviously here just to keep track of what's the current snapshot of rate, so that you can present everything. So now, this was the moment where we considered Rabbit for that job. This really started by looking over what we actually need and what Rabbit and different queues support. That's how Rabbit won. So let's start with the beginning. We want some sort of pattern matching. So for example, if multiple people will subscribe to the same Euro-USD rate as of the same date, we still want to send a single message in the system, don't duplicate them, and let the framework handle it. So that's what Rabbit offers under the topic exchanges. They allow us to label everything with certain keys, and then the keys will be matched based on patterns to different clients. It also supports matching by wildcards, so if we substitute any of the rate or the actual date, you're able to stream all euro rates or all USD rates or whatever else you want, even though in most cases you would just want the explicit rate. Also, since we expect a lot of duplication in the messages, the default mechanism for serving messages to queues is the first one wins and nobody else gets those messages. To go over that, we have the fan-out queues, so every matching binding will be notified and the message will be automatically cloned by the Rabbit. Also, there are different types of rates. Some of them, like Euro USD, they are pretty liquid and you get thousands of updates per second. In that case, you don't really care if you lose, say, 1 or 2 updates. But there are less liquid currencies as well. For example, USD INR, in that case, if you only get a couple of updates per minute, losing messages is suddenly not that good. Another part is the configuration, which is usually a tricky part. But fortunately, in case of RabbitMQ, they just offer string-based configuration. And whenever they have this nice feature that whenever you request the same config value twice, it won't fail, it will silently do nothing. Last but not least, it had to be available in .NET because most of our stack is available there. So once we went over how Rabbit fit into the topic, that's what changed. Again, the right side will be fixed forever. Now the business logic suddenly changed to topic exchange, and we decided to ship the streaming library, which is essentially a .NET library. Each library for each client would just spin up a local queue, and the action of subscribing to a rate just means creating a binding between topic and the queue. There is obviously the question how messages are pushed to the topic exchange, and we initially decided to just publish everything, regardless of people are actually streaming or not. That's basically a test of whether topic exchanges can handle lots of the data, and apparently they can. So that's what we ended up doing. Now, the tricky part is that if you increase the number of clients, I mean the physical instances of streaming library, you introduce lots and lots more bindings on the topic exchange, and after a few thousand of bindings, the performance drops significantly. So the way you can get around of it is by clustering the streaming part based on the configuration. Because again, the only connection between the library and the exchange is its name. So if you can hook into the configuration piece and load balance the exchanges based, for example, on the either number of bindings or the incoming outgoing message rate, you can create clusters that would speed up the system. That part, unfortunately, is out of question. The connections to the external source are limited. Also, they are really costly. So we have enough of them to support active-passive config and also to support our test environments. But we can also always get around of it by introducing multiple exchanges and just cloning the messages. So at that point, we were able to stream the exchange rates, also the forward rates, I mean the market data, and that's really important. And so far we went, it's done. Unfortunately, there was a classic case of miscommunication. Everyone cares about market data, especially clients, but nobody uses it at all. I mean, if you have, let's say, assume that blue dots are market data points. If you have 6 months forward, the chances that your client will pick it up are close to 0 because the dates are usually matched to their fiscal year. So usually it means they will pick something close, but let's say 5.5 or 6.5 or anything that for as long as it's not market data, they will pick it. So suddenly we cannot stream it. And that's where the idea of forward curve comes into place. And this is really an aggregate that gets all the values, maintains it, and whenever you request a point from the curve, it's just going to do interpolation. In case of FX curves, it's perfectly fine to do linear interpolation. If it's some other market data, for example, volatility, that's a talk on its own. The algorithms are different. So how did it fit into the design? Again, from the API point of view, nothing has changed. You still pick up the date, you still pick up the currency pair, and you expect to get the results. Now, from the implementation standpoint, suddenly there is yet another service, and its main responsibility is just to get all the forward curves and keep track of them. And now the library, once it subscribes for a forward curve, will do just a simple ping to the forward trade service saying, by the way, I'm gonna need that curve, so just do what you need. In turn, the forward service actually is a streaming client right now, not a, let's say, physical client. But still, the way it works is that it subscribes to underlying market data in the same way as regular client would do. And whenever there is an interesting update, and by that I mean, let's assume you want to stream a point that is somewhere here. If any of the points on the border change, you will get an update. If there is a change to curve somewhere here, if nobody cares, nothing gets sent. We don't want to send messages that won't be picked up. Anyway, at that point, we went over how to get the exchange rates, how to alter our view and include something called forward rates. The other thing was how to aggregate the rates into what's called forward curve. So the standard question is it possible to aggregate forward curves? And unfortunately, it is. So this is what's called triangulated currencies. The math behind it is that if you have two currency pairs with a common currency, you can either multiply them or divide, and you can arrive at yet another rate. So in this case, if you have USD PLN and PLN BHT, which is currency of Thailand, you can create a custom rate. And from the equation point of view, it's valid. From the market point of view, it's not fake, but it's artificial. Now, why would anyone like to use it? This is mainly used for exotic currencies. Unfortunately, you can trade everything against US dollars, because US dollar is the king. Unfortunately, you cannot trade other currencies so quickly, and this is related to liquidity. For example, if you would like to get that rate directly, there are very few banks that offer it, and that usually means the price is not competitive. So you cannot estimate what's the fair price, but you can get a rough guess. If you take those two rates and combine them, you know more or less what's the market view. Now this, of course, adds additional complexity to the forward rate service part, because Suddenly, it has to keep track of whether you have a forward rate or if it's a triangulated rate. And fortunately, you can only combine 2 forward curves. You cannot combine 4 or 5 or more of them. That's fortunately out of the scope. So what you could do in this case is to make a forward rate service actually a physical client of the streaming library, except whenever client requests something from streaming, you would just call the rate service, and it could find out that, hey, this is triangulated currency, so how about I just stream both of them and publish the updates. That also allowed us to validate a lot of assumptions about our API. But having all of that, that's fortunately all. And we were able to get to the most interesting part, so the performance results. So our initial idea was to check the very basic case. Let's assume that we have 10 physical instances and of the library, and you take 10 currency pairs at random and stream each of them for a certain number of dates. If you multiply those numbers together, you arrive at the estimate for physical users. And the idea behind the test, because you want to know how fast is your application, but you need to also derive a measure for that. So since our provider sends at most 4,000 messages per second into the system, that's not much. However, if you introduce some streaming clients, and if you increase the number of currencies, you can easily scale the number of messages. So our first criteria was that the local queues, the ones that you can see here, they have to be empty all the time. The incoming message rate and the outgoing message, the processing rate, they have to be equal, because otherwise it means that the messages are growing on the queue. And right now you may be given a rate from the previous hour. That's not really something you want to do. And once we did that, the test would just increase the number of incoming messages just to see what's the number at which queues are not empty anymore. So in this case, for a simple case, we have 1,000 messages per second that we can accept. The next 2 cases were built just to check the load on different parts of the system. In the first case, since we have multiple dates and multiple rates, we're just checking how much overhead we have for keeping track of the curves and the interpolation part. And that estimates, let's say, 10,000 users. It ended up having 7,000 messages per second delivered to the physical instances of streaming library, which is quite nice. But also it stays in line with the third line, which estimates the same number of users, except we're only checking if the load on forward rate service matters at all. So we have few currency pairs and few dates. There is virtually no interpolation, no updates, and you only scale your solution by the number of bindings. Fortunately, the results appear to be close. So there is really no bottleneck around forward rate service. And then there are 2 large-scale tests. We are just trying to see what is the moment where the entire solution will collapse. Because there is always a question, how many instances of RabbitMQ you're gonna need? Can you use single exchange? Is it possible to push data to multiple exchanges? And in both tests, we managed to process all the incoming data and still have reasonably good message rate per second. Now still consider that we have, in this case, we have 100,000 clients. They are not getting update per second. but there are different forward rates. As I mentioned, if it's Euro USD, you have lots of updates per minute. If it's something less liquid, you rarely get an update. There is also a question that messages are streamed in the market convention. So if it's, again, you can stream either Euro USD or USD Euro, it's still a single rate. It's just that it's gonna be inverted on the client side. So it's still a single message. And that's basically it. So I just wanted to thank you all for your time, and please enjoy the rest of the day. Thank you.